Okay, so Unit 1, Lecture 1. This is our introduction. To start, we're going to be watching the notes this year, so this is kind of your first time through to see how it works. So first part of this, what we are learning in this unit, the essential learnings. For this, first, formulate and revise scientific explanations and models. We'll be talking a little bit about some of the first scientific explanations of how living things continue with the Louis Pasteur experiments. We recognize and analyze alternative explanations, so this will also fall in with that discussion, because not everybody thought that life reproduce the way that they thought it did. And then understand and apply knowledge of interdependence of organisms. We're going to talk a lot in this first unit about how no organism is an individual within an ecosystem, that they're all interdependent on one another. And then most importantly, what happens when we start to lose some of those species and lose some of the relationships between organisms. And then the last thing that we're just going to touch on, we'll really focus on more in a couple of other units, is how we get matter and energy and the organization of living systems to keep cycling through so that we don't lose that material and lose that information or lose that energy. So these notes on the slides will follow directly with the notes that you have in front of you if you've printed them off, or if you haven't yet, make sure you get them printed off so you have them. And some of the stuff is extra, so you may want to write some of this down as you follow along in the lecture. Notice my lovely little, I need that t-shirt if I can find one. All right, so reviewing the scientific method, the steps. Pretty straightforward. You guys have done this 100 times. First thing is you got to ask a question. You want to answer. Whether you're doing research on cancer and whether or not a drug is going to cure that cancer, or you're studying viruses. Right now there's this huge outbreak of Ebola, and they're trying to figure out why it's acting the way that it is. You ask a question. That's the first step. Second step, did somebody already ask that question? Find out. Go out and find out what information is out there, what information is not out there, where are the blanks? And this can help you start to come up with an answer to the question that you have. For example, if we're talking about the Ebola outbreak and how to contain it, what has worked, what hasn't worked? Do we need to understand the terrain? Do we need to understand the climate? Do we need to understand the culture, which is playing a big role in why a lot of scientists think this outbreak of Ebola right now is much, much bigger than we know of, because a lot of the people that are being affected by it are in places that doctors can't get to. And so the numbers may be much higher than we think. Next, based on what you found in your research, do you have a possible answer or explanation for your question? Based on what you know, is there a way that you think you can fix it? Is there a way that you can answer it? That is what we call a hypothesis, a possible answer to the question. The question isn't the hypothesis. Okay? The question is not the hypothesis. The answer to the question is the hypothesis. And you don't state an answer as a question. A lot of people make the mistake of saying, well, their hypothesis is, will this work? No. We don't ask it as a question. A hypothesis is stated, the answer to this question. For example, one of the simplest experiments that people do is they can test